Hi ladies, today we're working on day 5, graphing linear inequalities. The notes here are actually very important, so you really want to pay attention to this right now. Definitely should be highlighting, because graphing inequalities starts exactly like graphing any other line. The only difference is that you have to worry about 2 extra things: the line type and shading. So let's first look at line type. In line type, if the inequality has a less than or greater than sign, use a, this is actually wrong, it should use a dashed line, and the points are not included. Please make those changes. If the inequality has a less than or equal to or greater than or equal to sign, use a solid. Ooh, that's not how you spell solid. Solid line, and the points are included. Okay, that is true. The thing about shading is that you determine which side of the line to shade on by using the test point 0, 0. Always shade in the side where the test point is true. So we're going to look at 2 problems today. Let's first look at number 4. Okay, so number 4, here we are. So saying that y is greater than x over 2 minus 4. Well, this is in mx plus b form, so we're definitely okay. We could just start graphing. So first going to look at your y-intercept, and that's negative source. So on the y-axis, I'm going to plot the point negative 4 because that is where the line will cross the axis. All right, that's right there. Then I'm going to use my slope, okay, m is equal to 1 over 2, to move and get to my next point. Now remember, it's 1 over 2 because x, the coefficient for x is 1. You just don't see it. Remember, that's invisible coefficient. So therefore, I'm going to go back to my y-intercept, and I'm going to move up 1 and over to the right 2. So then my next point will be right here. And I'm going to do it again. Up 1 over 2, up 1, and that should kind of put me over here in the air. Because I did the right, now I'm going to do the left, which means I'm going to do the opposite. So I'm going to go down 1 and to the left 2. All right. Now, I then have to look at my inequality. My inequality is going to tell me whether I have a solid line or a dashed line. Now here it's saying that it is greater than. That means that it will be a dashed line, okay? And any points on that line is not included. So now I'm going to make my dashed line, okay? My arrows. And now I have to determine whether or not I'm shading above the line or below the line. So I'm going to use my test point, 0, 0. I'm going to plug that back into the inequality. So 0 is greater than 0 over 2 minus 4. And that would give me 0 is, why won't it work? 0 is greater than negative 4. That is a true statement. So therefore, at this point right here, 0, 0 is included in my solution set. So when I shade, I have to include my test point. Okay? Now, if you noticed, I'm getting close to that line, the dashed line, but I'm not touching it. Okay? Because I'm saying that all the points that are very, very close to that line are included, but anything on that line is not included, so I don't want to touch it. Okay? The last thing you need to do is you need to label your solution set. Very important you do that. And I'm going to make a nice big S. okay? The reason why I'm making a big S, not a small s, is because I want my grader, Maria, to know that anything that is included in this solution set, anything that's included in this area is part of the solution set, not just a small piece of it. That's why you want to make a nice big S. The last thing it says is to identify a point in the solution. So any point would do. All right, 0, 0, you could use a test point if you want. Or let's just try a different point to see and show how anything in that inequality, in that shade area is true. Remember when we talked back in last unit about inequalities, inequality is more than one number as part of your solution. That doesn't include just one number. An equation has an equal sign. It's just this is equal to this. Where in an inequality, we're saying that anything can be greater than, equal to, greater than or equal to, less than or equal to, less than of something else. Okay? So let's just choose a random point. Let's choose, I don't know, 3, 1. This point right there, right? So 3, 1. That's definitely part of the solution set. Now you could always test it out just to double check yourself. All right, so then you'll say 3 is greater than, oh, I messed up. That should really be, hold on. This should be 1. All right, this is my y, and this is my x. So 1 is greater than 3 over 2 minus 4. All right, and if I were to put that into my calculator, 3 over 2 minus 4, that would give me negative 5 over 2. I'm saying that 1 is greater than negative 5 over 2, which is a true statement. Okay? We're going to look at number 6. So we're going to actually turn to page 12. And for page 12, if you noticed, number 6, this is not in the y equals mx plus b form. So my goal is to first get y by itself. So I'm going to first say what's happening to it. So it's being multiplied by 2, divided by 3, and then subtracted by x. So I need to do the opposite to get it away. So 2 over 3 y minus x is less than 4 over 3. I'm going to add x to both sides. And if you notice, I didn't line this up on the right side because they're not like terms. And now I would have 2 over 3 y is less than x plus 4 over 3. And then now I have to multiply everything by 3 on both sides. Here that'll get crossed out. So 2y is less than, distribute 3x, and here this actually just gets crossed out, plus 4. Now I have to divide everything by 2, and I have y is less than 3 over 2x plus 2. Okay, now I have my equation. Now I could go ahead and start graphing. So I start again with my b, which is 2. So I'm going to plot that first. Then I'm going to use my slope to move. So here's telling me I'm going to go up 3 and over 2. It's my next point. Can't go any more on the right, so I'm going to do the opposite to the left. Go back to my y-intercept, and I'm going to go down 3 and over 2. Down 3 over 2. Okay. I'm going to check out my inequality, which is right there, and I know I'm going to have a dashed line. So my line that I'm going to create is going to be dashed. It's the horizontal line. I have my arrows, and now I got to use a test point 0, 0 to see which way to shade. So back to my inequality, y. You kind of want to use your original inequality. That's the best way to check. So 2 over 3 y minus x is less than 4 over 3. And doing so, let's plug that in. 2 over 3 times 0 minus 0 is less than 4 over 3, and that's really just 0 is less than 4 over 3, and that's a true statement. So that means I'm going to shade towards that line. So when I shade, I'm shading this area right here. Again, I'm getting close to the line, but I'm actually not touching it. And I'm going to label my solution set nice and big. I'm going to answer the question, is 1, 2 part of the solution set? Well, where's 1, 2? Let's plot that point. 1, 2 is actually right here. And I would say yes, it is, because it is located inside the shaded area. Okay, you could always plug in 1, 2 into your inequality and explain it that way by showing your actual work and solving for it. Okay. Number 5 is similar to number 6. 1, 2, and 3 are similar to number 4. 1 and 2, please remember the Hoy and Oaks. Look at day 2 on graphing straight lines. Number 7, they are giving you the graph and you have to find the inequality. I suggest that you start with what is the y-intercept and the slope here to help you out, as well as looking at the type of line that it is. And number 8 is a throwback from Unit 1, okay, function notation. All right, ladies, thank you.